Alright, in this video we'll see another timer which is called on delay timer. On delay timer, and this is the block diagram of on delay. So here you can notice a small syntax TON, that is a syntax for on delay. So let's see what is this on delay and how does it work in S7-1200. So timer operation in Fpd Logic, timer on delay. It says the T on timer sets the output Q to on after a preset time delay. So after a preset time delay, it means it's a delay. Once the input goes on, the delay comes, then the output will be on. Okay, so let's see the different parameters. Data block, as I discussed before, this is the data block name. Now you have an input signal. So this is again 0 to 1 positive edge trigger, not edge trigger. It means if your input signal is on from 0 to 1, then only timer will be triggered, timer will be on. So if it says 3 seconds, so if the input is on for 3 seconds, at this point, when input is on for 3 seconds, your output will start and it will be on till the time input goes off. Okay, so we can pretty much understand that in the timing diagram below, but this is just to understand what is the input and output. So let me go off the pointer. So this is my preset time, as similar to PT timer. This is a preset time of 3 seconds, and this is the current time, which you can see here, and that's the output signal. So how does it work? Let's see the example. It says if preset time is 3000 milliseconds or 3 seconds, what will be the behavior? So as the input goes on here, I0.0, which can be connected to IN, the output will be on after the preset time. So this is the preset time which you put here, which is 3 seconds. So output is on after 3 seconds, and it will be on till the input is on. Okay, so this shows that if input is on for duration less than 3 seconds, so I don't have the marking here, but if you imagine this much duration is 3 seconds, and if input is on for less than 3 seconds, there will be no output. Okay, so this is the on delay timer. So let's try that in our Siemens TIA, a small example. I will take the input I0.0 and I will take a timer of on delay. You can find it here, TON, and the database I will put TON1. Okay, this is mandatory. So in PT I will put 3 seconds and estimated time MD0. Okay, now here I will take an output, which you can take any output. So I'm taking Q0.0 as my default first output. So let's download this logic and see the results, which is like if I turn on the input for 3 seconds, then only output will be on. So we are just going to visualize that. So the logic is downloaded. I'm turning on the monitoring from here, and the logic is monitored, and here is your PLC. Okay, so I'm going to turn on the first input, and you will see here the time will start. This is pretty much similar, so you will see time here as well and here as well. So I turn on my input and the timer starts. It's showing you in milliseconds and seconds, and after 3 seconds output is on, so you can see that here. Okay, if I turn off my input, the output will be off as well, because output follows the input after a time delay. So now the second case, if I turn on the input and I turn it off before 3 seconds, the timer reset and the output will not be on. This is the case which we saw in the timing diagram. Again, if I turn it on for more than 3 seconds, the output is on, and if I turn it off, output will be off. Okay, but if you want to latch the output, what you can do, suppose you want, when you turn on the input and after 3 seconds output is on, okay, and it should remain on even if the input is off. What you can do in that case, so I'm just showing you a small example. You can take a parallel output. So here you can take a contact. This contact should be same as the output contact. So you can put Q0.0 and you have to connect it here. So once it turn on the output, it will latch itself from here. So let's have an example, because this is we have already learned in the previous example. So you can pretty much customize your logic based on what you want to achieve in your application. So let's have a look. The monitoring is on, and here you have the PLC. Now in this case, the output will remain on if I turn off the input, because we have done the latching. So 3 second time delay, output is on. If I turn off the input, turn off the input, output remains on because it has a self-latching logic here. So to break the logic, I need to have a contact here or here so that I can turn off the output. In this case, I cannot turn off the output because there is no breaking mechanism for the latching. So I hope this is pretty much clear. So let's go back to the presentation. So we were here. Okay. So did you know fact changing PT has no effect while the timer runs? If the timer is running, if you change the PT, it will not affect the operation. Changing into false while the timer runs, reset and stop the timer, as we saw here. Okay, if you start the input here, timer start running. If you turn off the input, timer will reset and it will stop. Okay, so let's proceed with some example. It says write a logic to generate continuous pulse output for Q0, Q1 and Q2 in sequence with delay of 3 seconds. Okay, there might be some mistake here. Generate output, there's no continuous pulse. Right, to generate output at Q0, Q1 and Q2 in sequence with delay of 3 seconds, it means when you turn on the input, first this output should be on, then after 3 seconds another should be on, then after 3 seconds another should be on. So every output has a delay of 3 seconds. Once you turn on the input, after 3 seconds first output is on, then after 3 seconds second is on, then in 3 seconds third is on, and then nothing happens, all the outputs are on. This is the logic. So if you understand the timer on delay, you can generate this logic by yourself. It's pretty much easy. So the solution is here. First you have the start button. This button comes here. I'll take a pointer. Yeah, this is fine. So this button I0.0 is here. So if you turn it on, okay, I should better use green because red indicates stop operation most of the time. Okay, once the input is on, I'll put it as green. Okay, this timer starts and after 3 seconds I have a pulse which will turn on my output. Okay, so the first output is getting on after 3 seconds. Now notice the address here. This says timer1.q. So this timer1 means this timer, q means the output of this timer. So we are taking the address of the output. This output address comes here. So this output comes after 3 seconds. So after 3 seconds, I have a bit here which will be on automatically, which will start another timer for 3 seconds, which will turn on my lamp after 3 seconds of my first output. So there's a delay of this output and this output by 3 seconds, which is achieved by another timer, and its input is from the output of previous timer. Okay, so once this lamp is on, now you can also do one thing. You can also give the tag of this output here if this is confusing, because once the Q on output is on, so both the addresses are on at the same time. So you can either give the tag of this one here or this one here. Both will give you the same output. So once this bit is on, this will energize another timer, and after 3 seconds you have another output which is on. And again this Q is here and it comes here. So this goes on after 3 seconds of last output, this last output, and then this will energize this lamp. Okay, so this is a sequence command which you can use, sequence operation which you can use to turn on the outputs at different delays. Okay, so this is again 3 seconds. Now these 3 seconds because we have given the same time here, here and here. So all the outputs are on after 3 second time interval. So let's check that in our software, the same logic. So I will delete the previous operation. Yeah, this is fine. Now here you can take, I told you can take the tag of this one and this one. So I'll take both tags at different logic. So here first I'll take the tag of this Q. So how to take this tag? Notice the name you gave your data to your data block. This is TON1. So just type TON1 and you will see your data block here. Just click that once and you will see the tags which you can take in this contact. So I need a Q, just click that one again and you have the tag. So this is the tag of this Q. Now this is going to generate a signal for another timer. So I'll take TON here. So another data block. So I will take TON2 this time to make it look more easy. Time is 3 seconds. Sorry. estimated time, I don't want it here. Okay, now Q, another output, that will be Q0.1. okay, now comes another ladder. So this time I'm going to take the address of this output just to make it clear. So this is Q0.1, press enter, and then you need another timer, this time T13, and here I'll take another output, Q0.4.2. okay, great, everything is fine. Now what I made a slight change as per my example. I took the address of this Q1 here, T1Q here, and here I took the address of this output, just to explain you that this is not going to affect any difference in my application. So first, if I turn on my input, timer will start. Let's review that. It will turn on the output, that's fine. Then output, this Q will come here, and after 3 seconds another output is on, that's okay. Then this will turn on this bit, after 3 seconds this will be on. So our logic looks fine. Let's download that and have a look at the real-time operation. Load. So this goes off because the logic changed. Yeah, monitoring. And in this example, we cannot see all 3 timers in the same window. Let me just minimize that. Okay, this is fine. So here we have the PLC. I'll turn on my input. So this is on, time start. After 3 seconds the output goes on, and this Q comes here, time start again. This bit goes on, Q comes here, time start again, and the output is on. So if you see here, the timer takes 3 seconds to turn on all the outputs. Now if I turn off the input, all the outputs will be off at once because all the timer goes reset. So if I again turn on the input, you can have a look. First you have Q0.0, then you have Q0.1 here, then you have Q0.2 here. You can always extend the logic by having more timers. Alright, so this is a very simple application of a timer logic, how you can generate time signals in sequence. Okay, and if you want to have a look at the Fpd logic of that, that is also pretty much similar and easy to understand. So here we have Fbd Logic, which says you have first input I0.0, time is 3 seconds, and its output goes to 1 lamp. Pretty much easy. And then you have another timer 2 and timer 3. So timer 2 has the input of timer 1 Q. As I showed you in later logic, this is pretty much similar. And Q goes to lamp 2. And another timer on timer, there here input is timer 2.Q, this one here, and output goes to lamp 3. So this is similar to what we have done in ladder logic. So this is about the timer on delay. So let's review this lesson. We have learned that the T-on is used to generate on delay only. Okay, just on delay. And we can use multiple T-on in our logic to generate sequence of logics. We have seen in the example, the parameter of T-on are stored in a data block which can be accessed anywhere in the logic by using the specific address. Here we are talking about the timer 1.Q, which we have used in further ladders in the contact bits. Okay, so you can use that anywhere in your logic. So this is pretty much the application of using a data block. Okay, I'll see you in the next video.